What is a circle? Not how to draw it or not how to memorize its area, but how to understand it. The story of a circle doesn't begin with a curve, it begins with a triangle. Now, we start adding more sides as it becomes a square, a pentagon, a hexagon, and so on. As the sides increase, something curious begins to happen. The shape slowly softens, the corner starts disappearing, and before you know it, it almost starts looking like a circle. So, what if a circle is nothing but a polygon with infinitely many sides? That thought alone changes everything. But to move forward, we need tools. A mathematical tool chest, so to speak. The tool chest is what unlocks the secrets to understanding a circle. And the first tool that we need is the area of something familiar, a triangle, or more specifically, an isosceles triangle. Just picture one triangle sitting snugly inside the polygon. Its base touches the edge and its tip reaches the center. The length of the side is what would become the radius. The base becomes a tiny slice of the polygon's perimeter. At first, the math feels messy. But think about it. The area of a triangle is half of the product of its base and height. And with the power of trigonometry, the area of the triangle is found. Do you see where the story is headed? As you may have guessed, each polygon is made up of multiple triangles, and as the sides increase, the triangles increase as well, until there are so many sides that it almost becomes a circle, at least in its looks. And if one triangle has an area, then n such triangles have n times that area. Suddenly, the polygon isn't one big mystery anymore. It's just a collection of identical triangles, standing side by side, forming a familiar shape. So the area of the polygon becomes number of sides into the area of one triangle. Simple, elegant, and almost gratifying. Now comes the final step, the most important one. What happens when the number of sides increases and increases until n goes to infinity? The polygon tightens around the circle and the gaps vanish. The edges melt into a curve, and in that quiet limit, something magical happens. The polygon becomes the circle itself. Using everything from our tool chest, the area of a triangle, the limit estimation, and the angle of the triangle, the expression simplifies. And out emerges a result that feels inevitable. The area of a circle by r square, a simple formula with a surprisingly long story behind it. But wait, there's a twist in this story. Even with infinite sides, a polygon is still not quite a circle. A polygon has countable sides while a circle does not have any. Which is just a reminder that mathematics is not just about answers, but about approximations, limits, and the beauty of getting endlessly close to perfection. And so the story ends, not with a shape, but with an idea that sometimes to understand something perfectly round, you must start with straight lines.